Hi everyone, my name is Marzanul Islam and this is my Physics 2212 Lab 1 report for charged tapes. So as a basic introduction, the purpose of this experiment is to observe the interaction between two charged pieces of clear tape, to calculate the excess charge on a piece of charged tape due to the transfer of electrons, and then we're going to be using glow script to simulate the interaction. Some fundamentals used were Newton's second law, which is force equals to mass times acceleration. And then we're going to be using Coulomb's law, which says that the electric force is equals to K times the two charges divided by the distance between them. And then we're going to be using the formula that states that the electric force is equals to charge times the electric field. So a brief overview of the results we obtained were that both tapes became charged and obtained a positive charges. Due to both tapes becoming positively charged, they repelled each other, and the charge on each tape was 1.261 e to the negative 8 coulombs, and the tapes were deficient of 7.879 e to the positive 10 electrons. Some assumptions that were made were that air resistance was negligible. Each tape was treated as a point charge in which all the charges were concentrated at the center of the tape, and each tape that was used had the same amount of charge distributed evenly throughout the tape. And the system and surroundings. The system included both tapes, and the surrounding included everything else present in the room. So for the procedure, first I stuck a U-tape to a table and another U-tape on top of it, which is shown in the bottom left picture. And then I created two pieces of charged U-tape by ripping off the top one of the bottom tape. Then I determined the charges on the U-tape by moving it closer to various objects such as my hands, a negatively charged pen, and another U-tape. Then I held the first U-tape below the second one and measured the distance between them when they repelled each other, and I used this distance to calculate the electric force and the charge. So some observations I made were that tape 1 and tape 2 repelled each other. The tape 1 and my hand attracted each other. The tape 1 and a negatively charged pen, which I created by rubbing it against the cotton shirt, attracted each other. And tape 1 and a neutral book attracted. So therefore, I came to the conclusion that both tapes became positively charged. So now for my data and calculations. My data included the length of the tape, the width of the tape, the distance between them, and the mass of the tape. And then as you can see in the middle is a free body diagram of the force of gravity being balanced by the electric force. And then for my calculations, first of all, I found the force of gravity on the tape. So I just multiplied the mass of the tape times the acceleration due to gravity, which gave me 1.962 times 10 to the power of negative 3. And since the tape force of electric and the force of gravity are balanced, the force of electric is equal in magnitude to the force of gravity, which is also 1.962 times 10 to the power of negative 3 newtons. Now to find the electric force, I had to use Coulomb's law, and since we assumed that both of the tapes had the same amount of charge, I denoted the charge as Q. So the equation yielded to being kq squared over r squared. Then I isolated the variable Q, and then I found the charge to be 1.261 times 10 to the negative 8 coulombs on each tape. Now to find the number of electrons, I just divided by the charge of an electron, which yielded to be 7.879 times 10 to the power of 10 electrons. Now to find the ratio of electrons to atoms, I found the area of the atom, I found the area of the tape, and I just divided them. And then I got the number of atoms to be 4.06 times 10 to the power of 17 atoms. And for the ratio of electrons to atoms, I just divided them to find 1.918 times 10 to the power of negative 7. So here's my glow script model, and then as you can see, the code yielded the same values. So on the right hand side you can see the values, so the charge of the on one piece of the tape, the electron deficiency, and the electron to atom ratio. Some possible sources of error may have included the charges of tape not being equal in magnitude. The surrounding environment may have also affected the experiment, such as the AC, the humidity of the room, or my own handling of the tape, and calculation discrepancies due to rounding of many figures, as a lot of the values I used were rounded to 3 decimal points. So for the additional questions, what if the electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? If the electrons had a positive charge and protons had a negative charge, the same observations would be made, only that signs would be switched for our calculations. The tapes would still repel each other, but this time there would be excess electrons. And for the why question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? If the charge tapes came into contact with my hands or any other objects, electrons would be transferred from the object to the positively charged tape, which would weaken the charge on the tape. This would make it repel and attract other objects less and would make it difficult to obtain data to carry out the experiment. The experiment would also yield different values than if there were minimal interaction with other objects. So that's it for my lab 1. Thank you for your time.